I welcome you to lecture 31, the crop planning and rotation design in organic system. It is a continuation of the previous lecture, lecture 30. We have discussed in the last lecture the type of crops to be selected when you go for the conversion or the transition from the conventional farming to organic farming. So, what steps you should follow and the crop types, because at the beginning of the year when are you going for the transition periods, the yield may be reduced. So, to compensate the yield loss, we should choose the crops that require that have the demand of the less nutrients. And slowly as you go on with the progress of the years transition, then in third year you go for the organic labeling of the product. So, in that year you can grow the crops of the high nutrient demanding. By the time probably the soil might have been built up with the fertility due to the introducing leguminous crops or the low nutrient requiring crops. So, so that the yield loss in the main crop that can be compensated by the way of managing of the soil fertility. So, here we can discuss what is the planning of the how can plan the crops in a particular area or particular farm. If you are planning to convert your farm to organic from the transition periods and the organic production. So, what are the management and especially the crop selections, how you can select the crops. So, you can have a good returns, economic returns, at the same time you can have a better quality of the products produced in organic farming. So, as I discussed in the last class, the crop mix or the crop plan or the crop combinations or the rotations. So, that depends upon the on the four major components as you go for crop planning in the crop rotation plan. The components are on the resource, technology, market and institutions. These are the four major pillars when you go for the planning of this the rotation designs or the crop productions, because you need the resource means your the land, labor, capital, infrastructure. This comes under the resource, and also the natural resources, that means the climatic conditions of the location. So, that indicates what type of crops you are choosing. So, the resource, then technology means the technological knowledge. To build knowledge means the organic farming practices, the equipment is used for the organic farming, starting from your land preparations to the sowing of the seeds, the nutrient organic manure applications, then intercultural operations, weeding operations, spray plant protection measures, and finally the harvesting and post harvest processing too. So, the technology that indicates what type of crops you are trying to choose, what type of crops you are selecting in the rotation plan. Then of course, the market. So, I discussed market is very important, because your the selection of the crops depends on the market potentials. If somebody has to go for the productive or the have a the benefit economic, because we are going for the organic farming, have economic output, the better returns, higher economy. In that case, you have to see the market where you are going to sell your produce. So, that is as you discussed last class, if you do not know where is your market, how to sell your produce, better not to plant it. So, market is very important. Then institutions, that is a linkage where you can have a collaborations, where you can have a as a consultancy, feedback, advice you can take. So, you have to collaborate with institutions. So, these are the four major pillars of the crop planning. So, that indicates as discussed is then based on this the resource, technology, market and institutions, we can have a goal, the objectives, research goals. Then based on this market and the production options, the plan, we can have a crop mix or the crop rotations or the cropping system plan, and which can be changed in between based on the weather or the market. We can have a alternate plans to meet the demand or the to meet the objectives, and also at the same time it should be economically viable, ecologically sustainable, and that can give the maximum profit. This is how say the crop rotation plan. So, we discuss the effect of rotation crops, how they influence the especially the soil fertility. As you go for rotations, you see the as you have discussed earlier classes, when you go for the rotation design or the selecting crops in rotations, you should choose such type of crops, means there should be deep root crops should follow shallow root crops, cereal crops, maybe leguminous crops, because crops of same group should not be grown together, so that there should not be any competitions among the crops or between the crops for the nutrients or water, and also there will be less incidence of pest and disease. For this research report, I can see research informations. Studies have shown that organic matter losses from the intensively tilled row crops can be regained when the field is rotated with a perennial legume or short crops. That means, if you are growing the two crops, one is the corn crops that require intensive tillage, conventional tillage, and if you are going for the conventional tillage operations, then you can see from this figure. So, there is a decrease in soil organic matter, sharp decline in soil organic matter with the continuous cultivation of the corn crops, that means the conventional tillage. The with this operation, if you go to 0 to around 25 years, it is seen if you continuous corn planting with conventional tillage, there is a sharp decline in soil organic matter from the beginning to the end of this 25 years. And after that, what is said is first, the rapid rate of organic matter decompositions from tillage is stopped under legume or grass crop. If you go for the after that, there is a legume grass crops, then there is slowly increase in the soil organic matter content of the soils. That means, with conventional tillage and growing same type of crops, of course, there is a decline in organic matter of the soils, and as you replace the crops with the grass or legume crops, then there is a increase in organic matter content of soil. So, organic matter content again build up, that is accumulated as regained by changing the cropping pattern. So, that you say by grass or legume develop extensive root systems, and that are continually grow and also die up. The dead roots supply a source of fresh and the active organic matter to the soil, which feeds the soil actually feeds soil organisms, and that are involved in building soil aggregation. That means, having the grass crops or the legume crops, they leave lot amount of the huge amount of crop residue in the soils. So, that helps the active organic matter that acts as food materials for the native soil microbes, and they build up their populations by the time. So, in that way they can build the soil aggregation or the soil organic matter content. This is how the loss and gain of the organic matter with the change of cropping systems. As you go on from the corn planting to legume crops, there is an increase in soil organic carbons, and moreover, if you go for the tillage operation also, if you follow the minimum tillage or zero tillage, stubble mulch tillage, in that case also, so the organic matter or the organic carbon content can be regained, can be accumulated by continuously following the conservation tillage, as you say, or the stubble mulch tillage, minimum tillage or zero tillage operations. So, this research report has been collected from crop rotations on organic farms, a planning manual. There is a natural NRAES, natural resource, agricultural and engineering and services. For this, is how they have the long term experiment, where you have the where you have seen that say the building or the loss in organic matter or the change in organic matter content of soils by change in crops. And if you go to designing the crop rotation experiment, when you go for the evaluation of the rotation design, you have the two alternate plans, of course, based on your the market or the the resource and technology and the institutional linkage. We have developed some crop plan. Also, at the same time, as we discussed, we should have an alternate crop plan in case of weather uncertainty or the market fluctuations. To tackle those situations, we can have the second plan on table. So, so when you go for the evaluations of this or the designing of a crop rotation experiment, so there should be some of the things we should consider in mind. Flexibility. So, that means, so there is often a need to change management and includes that say new aspects of our investigations over the course of the experiment. So, that means there should have some rooms to make a change and make additions or the deletions of the some of the components as and when needed. Changes should be kept in an absolute minimum within a rotation course. That means, small changes can be accommodated. That means, this system should be flexible to accommodate some changes as and when needed during the course of the investigations. Then scale also, so better to have the plot and field should have a should be as large as possible, because when you are planning go for large scales, that means farmers field not exactly at the small plot in the experiment. So, the it should address the large scale that can be scaled up to larger area, and the time often as you go for the organic farming or the rotation design, it's a time taking process. So, if you continue for the more years, then you can have a better interpretation of the results for the evaluation of the cropping system design. And also when you go for the design you can choose as a factorial design, that is especially for this there may be 2 factors or more than 2 factors of the experiment for the evaluation of this rotation design. And the management detailed guidelines on the practical management of the crops and the plots should be formulated in order to minimize the effects of change in management over time. And that means this should be already the planning that should be made much before the implementation definitely, and the management staff often needs to learn the functions of rotations before the proper experiment can start. And of course, the minimum data sets protocols when you go for the experimental for the design for the evaluation of the rotation experiment, then the protocols of the experiment protocols that should be set, and the data minimum data sets, because without so that the effective for proper evaluations, what are the important data sets that should be documented, what are the methodology, and what type of data should be collected for the crop rotation experiment evaluation. So, this is the when you go for the rotation balance, this is a rotation design experiment, rotation balance. So, what do you mean by the rotation balance? Means when you go for the designing or the planning a rotation experiment, we plan for the seasonal, annual or the multi-year plan, and also we plan for the field scale and the farm scale. That means the field to farm, if you see a particular farm, there may be many fields, fields of can have different types, all the fields may not be same. Some fields may be upland ecosystems, a farm may have the area around 50 hectares or 100 hectare farm may be there. In that farm, some field may be upland, some field may be lowland, some field may be medium land, and also the field there are many entities may be there. Some may have some may have the crops, some may have the livestock, some may have the horticultural crops, seasonal crops. So, looking at those aspects, those entities or those enterprise, when you go for the rotation balance or the rotation design, we look for the annual and also the multi-year rotations. Annual means if you make for annual plan, that gives a seasonal returns, every year returns, that leads to economic output. So, every year there should be some return. So, that is as a business plan. So, there should be return of every year, and the multi-year, that is a perennial crop, because when you have the crops like perennial crops, you have the orchard crops, that is the fruit crops, and you have the other entities like you have the livestock or the poultry, where you return you may not get in the beginning of the years. So, return you may get after 2 years, 3 years depending upon the crop or depending upon the enterprise. In that case, that is a multi-years. For those conditions, we look for the mainly that focus on biology. That means, when you go for the multi-year crop plans in addition to annuals, then multi-year overlapping over the annuals, then that indicates in addition to economic returns, it indicates other values like biology, means it should give a better output, the production should be high. At the same time, it should have environmentally sustainable, means there should be less emission of greenhouse gases to the atmosphere. So, having the multi-year plan, so that means the enhancing soil fertility, the maintaining soil fertility in the long term basis, that is taken into account when you go for the multi-year crop planning. That means, building the soil fertility, or as you discussed just before, or the increasing the soil carbon content over the years, that comes from the multi-year crop rotation or the multi-year plans, having them different entities that together in the systems. And also we should see that the less emission of, that means greenhouse gas at atmosphere, the system should have the less impact or no impact on the environments. So, that means there is a sustainable environments that minimizing greenhouse emissions. At the same time, we have the better productions and the better quality, food quality, because as you are going for the organic concept, you are using the organic input management. So, it indicates there should be good quality, the quality of the food is much better environment. So, less pollutions of the water and less pollution of the air. So, better environment and the high productions. So, this looks to the biological value when you go for the multi-year crop plan. So, as you see the rotation planning balances the management of field and the farm level decision on an annual and multi-year basis. The annual farm level decision lead to prioritize the business concerns, and the multi-year decisions tend to prioritize and accommodate the biological demands that are discussed. So, there should be income generation, it should have the high income, high profit. Profit should be maximized. At the same time, if you go for the multi-year planning, you should see, so the sustainable means there is a less effect or zero effect on the environments, and also there is a build up of the soil carbon, the soil fertility is improved over the years, and at the same the quality you get the better and better quality for the better human health. So, as you see the rotation balance, so these are the components as we are discussing here. Crop rotation requires multi-dimensional thinking. So, when you go for the planning or the design as a field scale or the farm scale, integrating the farm scale you will integrate the field scale, because in farm there may be several fields. So, you have to, when you go for the planning of these rotations, you have to take account of the field, at the same time the farm as a whole, and also annual and multi-year. You think the long term planning, thinking the and also multi-dimensional means number of entities, how many entities we can accommodate in the farms. So, like the crops, livestock, or the fishery or the poultry. So, those units of multi-dimensional thinking can be taken into consideration when you go for the crop rotations. And the rotation management requires understanding both the whole farm and the each individual field, and balancing field and the farm scale decisions. So that means as you discussed, the field may be in the farm, all field may not be of same fertility, or the may not be of same topography. Some field may be a highland, some field may be lowlands. So, that means when you go for the rotational design, you have to consider, you have to have a decision making process, you have an understanding about the field where you are operating and the whole farm as a whole to have a proper decision. Then on successful farms, rotation planning is a rolling and the responsive process. As you go from rotations, so you should get response from these rotations, and expert farmers are continually balancing annual and multi-year decisions, because as a short annual means short term plan and the multi-year is long term plan. So, when you go for the rotation design in a farm, we look for the both, we look for the annual and we look for the multi-years. So, annual plan means that gives each year return, that means from seasonal crops like you have the vegetables or maybe floriculture, or the field crops like the cereals, oilseed, pulses. So, those crops are rotated. So, they give the annual returns or the return every year, maybe every 6 months you can get the returns. And the multi-year planning where you have the perennial crops like the orchard crops, or you have the different entities like you have the livestock, poultry, fishery. So, there you can get the return from return multi-year. That is so both the short term and long term is important, because annual and the multi-year planning is successful for this rotation design. So, business decision must be optimized for annual returns and cash flow. Then expert growers indicate that in any given season, market opportunities and logistical needs may override the biological concern. That means, depending upon the market potential, if there is a market for depending upon the crops or the entities. So, as we are planning, so we are looking at the market. So, what is the demand of market, which crop you can grow, so that you can sell it very smoothly, very comfortably, and you can get a good price. So, that is taken into account. So, that is a major factor that decides the crops to be grown. Then experts manage multiple interacting factors as they implement crop rotation. So, those things as you go on process of rotation design. So, either the nutrient management, the pest management, weed management. So, those are taken care. Organic farmers rely on rotations and long term soil quality to deal with the problems and ensure the productivity on the field. So, that as you discussed already this one. So, we need the long term soil fertility. Soil fertility has to build up, enhanced long term basis in organic farming. When you go for rotations, and that should take into account how you can build up the soil fertility over the years. And then you go for the organic transition or the production plan, how you can go for the organic production. So, these are some of the steps you need to follow when you go for the organic transitions, and this plans has to be taken care when you are converting your field from conventional farming to organic farming. The first one, the set your objectives, because this is for any business. If you go for the any business, or is farming is a business, then you have to set your objective. What is the objective for what you are going to make a organic? So, you are going for the field crops or the vegetables, the horticulture, orchard crops, or the poultry or the livestock. So, depending upon this, or you have integrations as you say. So, that means your objective has to be set, what you are going to do, what production, what type of production, depending upon the then you have to take care of the climate and the resource and the technology and the institution. Based on that, you have to set your objectives. What is your objective? Suppose somebody objective has only to produce the vegetables, the cash crops, vegetable crops, keep fresh vegetables in the field. So, or somebody has to the milk productions or maybe meat productions, or some have integration of all vegetables, cereals, grains, oil, seeds and meat productions. Based on the resource, technology available, institution, market, you have to set your objectives. What type of entities or enterprises and what should be your objective, accordingly you can set your objective. Then follow part by part transition to organic. Once you have set your objectives, then go for transitions for a field. Suppose you will give example of a field crops. If you are going for growing a field crops, then you have to divide the field into 4 parts. Suppose this is a field where you are going to have the crops, maybe vegetable crops or field crops, cereal crops or the oil seed crops, the pulses. In that case, you divide the field in 4 parts: field 1, field 2, field 3 and field 4. And also you can the area that depends upon the type of the topography of the soil. Suppose some field is upland, lowland, medium land that depending upon the field situation, you can have a 4 almost equal parts or maybe some uneven, that is no problem, but you have to divide the field into 4 parts. Then make a cropping plan in transition based on market potential and transition needs. So, if make a cropping in the transition periods. So, from one field you can start part by part. So, field 4 or you can start the transition, and the crop planning depends upon the market or the resource available, technology and the institutions. So, there you can have a plan here, implement this on the field 4. Then analyze the economics of this transition. So, looking at the history or the information from the various experiments. So, if you go for that transition, the plan of the organic the production plan for any type, any field, then what is the returns, then you can have the economic returns of that plan. Then prepare an alternate plan in case of weather and market uncertainty. So, looking at the, as you see, market uncertainty, or there may be weather fluctuation, sometimes it may be dry years, sometimes may be very wet years, or the flood or the drought. Looking at the extreme conditions, we can have the second alternate plan must be ready, because weather you cannot, the prediction you cannot do for a long term basis. So, when you go for the seasonal plan, so based on the future weather, I mean 2 months or 3 months weather, forecasting whether the rainfall or the monsoon should be normal or there is some variation or the dry conditions. So, depending upon that, a crop can be changed actually this one. Suppose you are planning for a rice crop in case of the upland ecosystem or the lowland ecosystem, upland ecosystem, based on the normal rainfall, if the monsoon is normal. In case there is a fluctuation monsoon or the prediction there will be dry years, there will be variability in the monsoon, then you may switch over from rice to some other crops, like corn crops can be taken instead of rice crops, because corn crops require less water, that can survive in even if the less rainfall areas. So, accordingly, so you can have a alternate plan, or in case you have the very flood years, you are planning a flood years, there may be flood condition. In that case, you have chosen some other crops, you can shift to rice crops which can sustain under the flood conditions. So, likewise, prepare alternate plan, and in case of the weather or the market uncertainty, same for the market uncertainty. Once you have the plan ready, then acquire resources and organize the use of resources within timeline. So, once you have made the plans for the transition or the organic productions, then accordingly the resource should be, the source of the resource should be gathered, acquire the resources and organize the use of resources with timeline. Then the time schedule, activity time schedule should be prepared, at what time, what type of activity should be performed to attain or to reach the goal. Then implement the plan and follow record keeping at every stage. So, that is very important, as you discussed also earlier class. Whatever you do in organic farming, record keeping is very important, starting from the land preparation, or you have got planning, from planning, then land the acquisition of resources, from where you are getting resources, suppose seeds, fertilizer, the manures or seed stock, from where are you getting, those should be documented, proper records should be there, and up to the harvest and post harvest, whatever the operations you are performing, each operation should be documented, because those documents because you will be requiring when your certifying agent will review and audit your records, that is required. Documentation is highly essential. The record keeping is very important when you go for the applying for certification process. Then make decisions and take action. This is very important, as and when needed to solve any problem and evaluate the resource of the result of the decision. That means, what you say, suppose that is anything unwanted things may happen, because unexpected things may happen during the course of the experiment, because planning, because suppose you have the plan there is a immediate or the sudden outbreak of any disease or the pest. So, that we are not usually prepared to tackle. In that case, so you have to take a quick decisions and also implement the actions as quick as possible of your decisions, and at the same time you have to evaluate this the results of the decisions, whether the decision was proper or wrong decision. It may be wrong decision, sometimes not necessary that always your decision may be right, sometimes it may be wrong decision, but you can get a learning. Even the wrong decisions you can take a learning, you can have a learning of this your the decisions. Then you have to analyze the results of these decisions, then monitor the progress towards the goal activity. So, regular monitoring, so in between, so there is regular assessment. So, whether we are meeting or we are attaining as per the goals. So, these are the steps that should be followed when you go for the organic transitions or the conventional field to organic fields. That means, you have the field, you divide the field 4 parts and go on the transition, have a plan, transition plan, and go for the implementation of the plans from the year, the transition year. So, as you see example, you can give an example for the transitions. So, this is a field plan of organic rice-chickpea system. So, this is a whole field. So, this divided into 4 parts: field 1, field 2, field 3 and field 4. In case of field 4, so when you go for the transition, so leave field 1, field 2, field 3, start your transition from field 4. From field 4, you have the crop transition plan. So, here we have taken the beginning of the transition, you have the system of rice-chickpea, you want to have the rice and rice-chickpea your main crop for the systems. In this case, transition years, we are introducing soybean in the Kharif season, followed by radish in the dry season, the winter seasons. So, the purpose of having soybean and radish, I have discussed, these are the crops which require less nutrient, less demand of nitrogen. So, having soybean or the radish at the beginning of the transition, that can, so that we can get the same yield level can be maintained. So, the yield loss can be compensated having the soybean and radish, because they have the less demand of nutrient. So, through organic farming we can attain the yield as of chemical farming for those type of crops, soybean and radish. So, and the second year we are going the same soybean crops and the carrot. Soybean is a leguminous crop, so in the way it can fix atmospheric nitrogen and it can build up the soil fertility. And the next we are changing the carrot crop. Carrot is also a low nutrient demanding crops. And once you have done the 2 years, then you go for the third year, the main crop as you are the system, rice-chickpea system, and this is the third year, the product can be labeled as a organic product. And from the third year you can, because you already have followed transitions for the last 2 years, and you can apply the certificate in the third years, and third year will be a review process. There will be proper revision and the verification of the system of the production systems. Then you can apply for certificate, you can get the certification organic, you can sell your produce as organic from the third years. So, similarly from the field 3, so you can go for all the fields are conventional, and the field 3 second year you can start for the transition, and accordingly you can get organic in the 4th year, and same process for field 2, you can go for transition from the 3rd year and you can get the organic the produce in the 5th year, and finally the field 1 you can start the transition 4th years and you can get organic in the 6th year. That means, after 5th year, from 6th year onwards the whole farm is converted to organic. So, by step as you go for this one, the organic we can get the whole farm organic from the 6th year. We have one economic analysis of this system. If you see, after 3rd year we did analyze what is the economic returns of the organic rice-chickpea system. So, we compare 3 fertilizers. One is from this our experiment, where in one plot we applied no fertilizer. This is grown as a native soil as a control one, and the other plot we applied only chemical fertilizers, and the 3rd plot organic fertilizers, that means no chemicals. So, in this if you see the yield of rice and chickpea, so in case of no fertilizer control, yield is very low, and the chickpea was grown on residual fertility of rice. No fertilizer applied to the chickpea crop, only fertilizer was applied to rice crop, and chickpea was grown after harvest of rice in the same soil without adding any fertilizer, even if a chemical fertilizer or organic fertilizer. So, that is why you see the residual effect of no fertilizer is nothing, because the chickpea yield is very low. And same for the chemical fertilizer, that is a very, because as you discussed earlier also, it is a very short acting, and also this is the very fast release, and it has very low or no residual as good as a no application of fertilizer, because yield remains same chickpea whether you go for non fertilizer or the chemical fertilizer, they have no residual. But if you see up organic fertilizers, it has a high residual effect, and the yield you are getting from the residual of organic is 650 kg per hectare, whereas in case of chemical fertilizer is 105 kg per hectare of chickpea yield. That means it indicates that organic fertilizer has high residual activity. It can, because of residual activity of organic fertilizer, that can meet some of the nutrient demand of chickpea crops, it can give some of the returns which is significantly higher than that of chemical fertilizer. And with this, if you see that this is the cost of production of both rice and chickpea, and the gross return of rice and chickpea, and if the net return in case of no fertilizer, there is a loss around 20,850 rupees per hectare, because because you are spending everything, land preparation, seeds, labor, everything, irrigation, you are putting everything on no fertilizer. So there is a negative return, the last one. If you are going chemical fertilizer, the return is around 37,625 rupees per hectare, whereas if you are going for organic fertilizer, the return is around 51,300 rupees per hectare. And if see because there is a increasing return, we have put in organic fertilizer, organic farming as compared to chemical farming, the selling price of the produce we have kept 23% higher in organic farming as compared to chemical farming. And also there is a production cost is higher in organic farming, because you are using the vermicompost, that is a high dose as compared to the chemical fertilizer. So because of that, the production cost is higher in case of the organic farming, though there is a high production cost, and because it is a high residual effect, and it compensates the nutrient requirement of the succeeding crops. So we are able to get the higher return in case of the organic farming as compared to chemical farming. So the point is that here when you go for the rotation design or crop planning and rotation design, you should keep in mind that the type of crops you are choosing in the beginning at the transition periods, when you are targeting a main crops, transition periods, take the crops which requires low nutrients and less maintenance, and that can suppress their weed growth. In that way, we can build the soil fertility for your main crops, and also different type of crops combinations should be chosen. And you go for the economic analysis, you can see that the organic farming that will give, if you do properly with proper management, scientific management, organic farming definitely will give the better return as compared to the chemical farming. With this, I conclude this lecture. Thank you very much.